All right, last example for a separable differential equation. I have dy dx equals x to the fourth times y minus 2. The first step is to separate the variables. I'm going to imagine multiplying both sides by dx. So I'm going to get dy equals x to the fourth times y minus 2 times dx. And then I want to undo anything on the right that looks like that has a y in it. So I see y is having 2 subtracted, and that's collected together with a grouping symbol. So to make that y completely leave the right-hand side, I'm going to divide both sides by y minus 2. This leaves me with dy over y minus 2 equals x to the fourth dx. So on the AP test, if this was the free response section, that would be worth 1 point because you've now separated the variables. Everything y on the left, everything x on the right. So I'm going to jump over to the whiteboard and start from here. All right, so I've separated my variables, and now I'm going to need to integrate both sides. So imagine throwing it, integral sign on both sides. And we have, right, the antiderivative of y over 2. So if you want, you might think of making a u substitution. So u equals y minus 2. du is just 1 dy. So du is equal to dy, which means that when I do this, when I want to integrate here, that's just going to be 1 over u times du. You might get to the place where you can just say, well, whenever my u and my y have the same derivative, maybe I don't need to write out that step. So that's up to you. I'm going to go here. I end up with du over u. The antiderivative of du over u is going to equal the antiderivative of x to the fourth. Well, the antiderivative of du over u is natural log of the absolute value of u. Antiderivative of x to the fourth is x to the fifth over 5. And I can put my u back. So the natural log of the absolute value of y minus 2 on one side is equal to x to the fifth over 5. Don't forget plus c, plus a constant on the other side. So this point on the AP test, you've earned, probably 3 or maybe even 4 points. 1 point for separating the variables, 1 point for integrating, especially with a u substitution on the left-hand side to get natural log of the absolute value of y minus 2. Probably another point for getting the right antiderivative on the right-hand side. And maybe even a 4th point for remembering your plus c, your constant of integration. So now that I've got my 2 antiderivatives, I'm going to need to figure out what my c is or try to isolate my y. There are 2 things I need to do. I actually, in a problem where I have natural logs that I have to undo, I like to do a little bit of isolating first, trying to isolate y until I can rewrite my e to the c as a capital A multiplying constant like we did in that last example. So I'm going to show you what I would do next here. All right, to undo natural logs, we exponentiate both sides. So I'm going to make both sides the exponents on a base of e. So I have e to the natural log of the absolute value of y minus 2 is equal to e to the x to the fifth over 5 plus c. But that e to the x to the fifth over 5 plus c, I'm going to rewrite as e to the x to the fifth over 5 plus times e to the c. And then e to the c is just some constant raised to some constant. I'm going to replace it with a new constant, which we typically call a. You can see here, I got a little excited and I actually undid my absolute value bars first by putting a plus or minus sign. If I do that, then positive or negative e to the c is just some number, positive 1 or negative 1, times some base, 2.71828, raised to some constant power. You can actually group all three of those symbols together in your new constant, which I'm going to call a. Now I can use my ordered pair that I was given at the beginning. I know that when x is 0, y is supposed to be 2. Sorry, I know that when x is 0, y is supposed to be 0. So I replaced this x with 0 and this y with 0. And I have my new equation. Let me get the blue marker back. So that tells me that a is going to equal -2. So I replace this a with -2. And I have there we go. So y minus 2 equals -2 e to the x to the 5th over 5. I'm just going to isolate y. That's by adding 2 to both sides. I'm going to double check my work. If I replace x with 0, I'm going to have e to the 0 is 1. So 2 minus 2 times 1, which is going to be 0. And that confirms for me that 0, 0 is an ordered pair on my solution. So final answer.